topic aligns math and history, and we're going to be taking a look at piecewise functions in real life. So, in the previous video, we learned that a piecewise function is able to have at least more than one function on one graph. There can be two or more functions on a graph to make it a piecewise function. We also explained that a piecewise function can actually tell a story without any words, because those kind of stories that we're going to be telling is going to be about your speed, your distance, and your time to complete the task. So here's an example. We have a graph, and on the top of that graph is going to be your y-axis, and the horizontal is going to be your x-axis. When we take a look at speed, distance, and time, let's take a look at your distance first. The distance away from where you start, which is going to be right here. So, your distance is going to be your y. And your x-axis is going to be your time in seconds. So here's an example where it would tell a story, but we're only using one function right now. Imagine you're at the beginning and you want to start moving forward at a steady pace, and your speed does not change, but your distance does. Since you start here, you will want to walk slowly away from the purple dot that you walked away from. What the thing is the time in seconds is increasing. You can't pause time. And number two, your distance between the start or where you started is increasing. So you're going away from the starting point. So what Mario just did is he walked from the flag that he claimed that had the M on it, and he walked slowly away from the flag. Let's find an example where we use distance as y again, and we use their time in seconds as the x-axis. But only this time, you want to approach the flag or your starting point. You want to go from any point on the graph and get straight to here. Okay, so we have another empty graph. We have distance and time in seconds. Imagine if you want to get to here, but you start right here. What you want to do is get from here to there, but how? There is one thing that you can't do. You can't go straight down because time is always moving. You can't pause time. And number two, to get from here to there, you would have to be at your destination at the same exact time you started. You can't do that. Only starships with hyperdrives can. You can't right now. So to get to your starting position, you're gonna wanna walk at a constant pace or speed and somehow get to your destination. But on a graph, it will never be a straight line. It will be a slope, but not exactly at 0. It will take probably 1, 2, 3, 4, 5 seconds to get from here all the way back to your starting position. This can prove why slopes can never be a straight line.
Course set for Earth. 10 seconds to hyperjump. 9, 8, 7, 6, 3, 2, 1, 0.
There is one more type of function that you will need to know in order to start doing piecewise functions in real life, and it is a horizontal function. When you see a horizontal function on a graph with distance as the y and time in seconds as the x, that indicates that you are not moving. Let's say that from this point here to there, it is 2 meters, and you're not moving, so it's a straight line, but the distance does not change. The time is always tick, 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 ticking, and you cannot stop time. So even though time is still going and you're not going anywhere, it will be a horizontal line. So these are examples of what a slope or a line on a graph would look like when you make these actions. But what happens if we walk or run with different speeds? What happens if we speed up or slow down or we run in different speeds? So, here's an example. When people run cross country, they like to pace themselves and go all out in the end. And when people pace themselves, they don't go all out. They like to go at a steady rate and get to the finish line. So, here's an example of what a slope or a line would look like for the speed of cross-country runners while they are doing distances. But at the end, they like to go all out, and your slope is going to become a steeper slope, because since your time is going tick, tick, tick this way, and your distance is going more from the starting line, the steeper slope means that you're getting the running done, but in a faster time. This is when cross-country runners like to end up in the finish line. Now we know what to look out for when we see slopes that are steeper, slopes that are less steeper, when a slope is not moving, when you're going towards the goal, or when you're going away from the goal. Now, let's have story time. So what we're going to be doing is watching a short story, and we're going to calculate the distance from the planet because it's in space, and the time. So if you ever heard Pikmin, the game from Nintendo, then you'll probably understand about what the story and the sequel is. So, the president entrusted Louis to deliver the gold pick carrots to another planet. So, he waited for a few minutes, then took off. Then, he noticed that he ate all the carrots, and his spaceship was not moving at all, so we draw a straight line. Then he had to go back and descend and wait again and go back down again to lie to the president about what the problem is because he ate all the carrots. The thing is, that led the company to a problem, a financial difficulty. So, this is an example of a piecewise function because it has multiple slopes. This is a slope, that is a slope, this is a slope, and that is a slope. This can tell the story of Louis's dark secret when the president gave him the pick carrots in Pikmin 2. This can be an example of telling a story through mathematics. Thank you for watching Tao Penguin's Math Industry. Like and subscribe.